Hello, everyone. This is really welcome to Can.Do.So. Let's continue to learn R programming for beginners. This is lesson 9 and normal distribution part 2. In this lesson, we learned the basic concept of normal distribution, which is about what is normal distribution. And in this lesson, we will learn how to use normal distribution to solve problems. Let's get started. And first, we load the packages we will use in this lesson: tidyverse, open intro. This one is to draw the normal distributions pictures plot. And this is data we are going to use. And first, we can use normal distribution to find out the probability of the data. Unlike the discrete data, the y-axis is continuous. Data does not represent the probability of the data. So in a dot, it does not make sense to calculate the probability because that's 0. Because the continuous data in theory, it has infinite data. So in one point, the data does not make sense. The probability does not make sense. So we can only use the area under the curve to describe the probability of the continuous data. And we can use the CDF, which means cumulative distribution function, to calculate the probability of the data. And Fx represents the probability of the data less than x, i.e., which means the area under the curve to the left of x. And for example, we can calculate the probability of the data, which is less than 165. So F 165 it stands for P. The probability of X is less than 165 is how much? So use code, we can see we use plot show, which means 150 X is 165. So we want to find out the Fx means. So Fx, which means Px is less than 165. So to the left side of this line. And we can use R function to calculate this. R function is p-norm. And the first argument, Q, is the value of the data, which means this one. And in this case, and the mean is the normal distribution's mean, as we have covered in last. It's in the center of the curve. And the third argument is the standard deviation of the data. So in this case, it's 5. So from here to here is 1 standard deviation. And this example shows that the probability of the data is less than 165 is 15.87%, which means this part, this purple part, is 15.87. Account 15.87% of this Q curve side. Okay. And we can also calculate the probability of the data is greater than this one. So yes, so we want to find out this part. So to the right of the 165. In this case is 84.13. Actually, since the total area under the curve is 1, so if we have already know this part, we can use 1 minus this part to get this one. Yeah, in this case is this. And we can use, yes, 1 minus P norm Q is 2 pi to get it. No surprise, the result is the same as above. Here. Yeah, this one. So, and the lower case is if we use this part, the lower case, which means we want to the right side of the area, and to the if we want to we take it to the default, which default is true, which means we want to get this part. And default argument, we can always omit it. So because we can use 1 minus this part to get this one, so this one gets the same outcome. And we can also calculate the probability of the data is between 165 and 175. So which means we want to get the middle part of the data. And we have plenty of ways to calculate it. First, we can use this whole part to the right, to the left of the 175, which means this one plus this one minus this one. So we use this one minus this one, and we'll get this one. So in R, we can use this 175 minus 165, and we get it. So this one is part is 68. This part is 68%. We will use this number, remember, just remind you. Also, we can remember that because this one we have no calculated that it, so we can minus this part and this part, which means we can minus this part and minus this part because the total is 1. So 1 minus this part minus this part, then we get this part. In R, it will be like this. So 1 minus this part minus this part. Remember, this part we have to set it as a lower tail is false. Because if lower tail is true, then it will calculate this part. And no surprise, it's also 68. And remember that this normal distribution is symmetrical distributed around the mean. So, which means this part and this part is equal. So we can do it even simpler. 1 minus 2 times of this part. Again, the result is the same as above 2. So in the next section, we know the critical values and we can find out the probability. What if we know the probability and we want to know the critical values? That's also possible. And first, understand the 68, 95, 99.7 rule. 68% of the data is within one standard deviation of the mean. 95% of the data is within roughly two standard deviations of the mean. And then 99.7% of the data is within three standard deviations of the mean. So 65%, 68%. Here I use a standard deviation symbol to show that here is mean and here is one minus a mean minus one standard deviation, and here is one plus standard deviation. So this part is 68%. And this part is two standard deviation from the mean. So this part is 95%. So which means this part is what? So these two parts add together will be another 5%. And also we know that this two part is equal. So we know that this part is also 2.5% and this part is 2.5%. And this part is 95%. Okay. And 99.7% will actually it's almost the whole area, only left 0.3%. So if it is not exactly the above probability, so not 68, not 95, 99.7%, what do we know? How do we find out the critical value? We use Coulomb function. So the code is, we use this. For example, here is not in the exactly the 1 or 2 or 3 standard deviation. It's in the middle of the one a little lower than the one standard deviation. So for example, we know if we know this part is 79%, so we can use this set P. Just now we use Coulomb. Here is Coulomb to find the probability, and Coulomb to find the cut, Q, similar to cut. And the P is standard, is part probability, and as usual, this mean and standard deviation. And we find the number is about 1,742. So it's here. We know that this one is 100, 500, and the standard deviation is so 1 plus 300. So there's 1,800. So a little below, so it's 1,700 here. It's 1,741. Yeah. And yeah, again, the only difference is the first argument is the probability of the data. Is this one, this part, and we can find the cut here. And we can also find the critical value of the data if we know the upper side of the. So if we know this part, so we can also find this value. For example, we want to find the, for example, this part is 37. So use this one, but we have to set it to lower pace because we want to find this part. So this one is because here is 1,500, so a little larger, bigger, so it's about 1,600. Lower tier equals to 4, so which means we have to calculate the value of the data with probability to the right of the data. And if we know the two part in the middle, we know this part. So what do we do? So if we know this part is 20%, and this part is 75%. So this one is 20% and 55% plus together is 75%. What do we do? So we use this one, P equals to C. So we got the two part. So this one minus this one. So we got this one. So here is lower than 100. I can show you that. Again, this mean is 150, 100. And the standard deviation minus 1 standard deviation. So there is 2,000, 1,200. So there is 100, 1,800. So a little lower than here would be 1,700. So here is 72. A little bigger than here. So it's here is 1, 2, 4, 7. Okay. So with our function, it's very convenient to calculate the probability. And we have also have another R function is R long. This one will create the normal distribution data. In this case, we set n equals to 100, mean equals to 0, and standard deviation is 1. So it's so we will get 100 data like this. It's normally distributed between 1 and this, and expanded as 101 as the standard deviation. The first argument is the number of data we want to generate. Here we want to generate 100. The second argument is the mean of the data. And the third is the standard deviation of the data. And we can use haste function to plot the data we just get. So this one is here, and we pipe. And here we change we can change the mean and standard deviation to 1,500 and 300. And so here we got, you see, this is a normal distribution. And this next part I want to show you the standard normal distribution. During a period when there is no computer, we cannot easily to calculate like just now I have showed. The scientists, statisticians have to calculate the CDF by hand. However, like I have showed, the PDF and CDF formula is quite complicated. So it's not an easy work to do. And it's very time consuming and easy to make mistakes. but scientists have a solution. So we use a standard deviation, standardize the normal distribution, and PDF of standard normal distribution is like this here, and and the standard normal distribution is like this, and we can compare to general normal distribution below. We see, so here disappears, the sigma square disappears, and here mu disappears. That's because we set the sigma is to equal as to 1. 1 square still 1, so we can cancel it. And the mu is to 0. X minus 0 is x, so we can cancel it. Then becomes this one. I show you a example to show how to standardize the normal distribution. For example, we have the, like just now we showed with mean 170, standard deviation with 5, we create 10,000 data, 10,000 value, which is normal distribution. And the first step, we divided the value by 170. So we divided each value by 170. Then we got 0, this center to 0. Okay. And the second part, we divided the new value by 5. Then the standard deviation will become 1. See, here is the standard deviation is here is 5, so it's quite wider. It's minus 10, and here's 20. But here, it's only, like we have said, this is 1 standard deviation, 2 standard deviations, 3 standard deviation, like normal distribution. Within the 3 standard deviation, it's cover almost 99.7%. But what do we do? What do we know? What can we use the standard deviation? One more thing. Use the standard deviation. We can use the table to find out the value of the probability and the critical values. I can show one example to the table. It's normally looks like this. For example, if this score is 1. Error under the standard normal curve. So in this table is he finds the right part of it's not a typical table. Yes, this one is a typical table. Typical table is to tell you the right part to the left part of the. So for example, here 1, as we have said, 1 standard deviation to the right part, to the left part is 84.15, 17. And if we go to the 0, which means the standard deviation is 0. So because we know that it's symmetrical, so this part should be 50%. How about less than 0? Less than 0, we can go to this part. We can go to, for example, if it's minus 3, we can go to positive 3 here. And it's positive 3 about here. So to this part, the right part is positive 3. And to the left part is positive 3, so it's 99.87%. And so we can use 1 minus this part, this one, and get this part. And because this part is equal to this part, so we can get a minus 3 data. But normally we don't use T-table now because we have R or other SPSS data to calculate, so we don't need it. But maybe you will use it because during some exams, the examiner will give you a table, so you have to use the table to find out the probability or critical values, z-score. And this one is if you know this score, and you can find the probabilities in here. And if you know the probability, and you can also find the score. Okay. How about how to use the standard normal distribution? Normally, if we have a different measurement of the data, and we can standardize the data, and we can compare it. We use an example of exam scores. A is 200. A got the score is 2000, and B got 89. But their measurement is very different. A's measurement is mean with 1500, and standard deviation is 300. And the B is with mean with 75, and the standard deviation is 5. So we want to know which score is better. So 89 is better or 2000 is better? We can take a guess. So we have first we minus the standard the mean, 2000 minus 1500, 89 minus 75. And the second part is to divide it by the standard deviation, 300. Here is by 5. And what do we get? So A is 1.7, and B is 2.8. So which one is bigger? B is much bigger, 2.8. So B performs better than A. So we can use the probability to show even more, even easier to understand, because this one is the A's probability is 95.22, and the B's probability is 99.7. So what does that mean? Which means A's 2000 score defeated 95.2% people, while 89 exceeds about 99.7% people. So B exceeds much more people, by percent. So B's score performs better than A. Okay, that's all for our today's lesson. And as usual, we have a homework. You can try to practice it. And if you're struggling with it, you can leave a message below and I can help you. And I will also leave home solutions on the website, which you can refer to. Okay, thank you for watching. If you like it, please share it, subscribe, and press the like button. You will help me to do much better, to offer better videos, lessons, tutorials in the future. Okay, see you next time.